Okay, welcome to part 2 of the binomial distribution. So here's a classic example. We've got Jim taking shots at a target. The probability that he takes, that he's successful is 0.4. He takes 10 shots. Let's do the checklist. Fixed number of shots, probability of 0.4, doesn't change, and there are two possibilities. He hits the target or he misses. So this is classic binomial. Let's look at the first question. What is the probability that he is successful with exactly 5 shots? So let's have a look at this as if it were a binomial. Well, it is a binomial. Now he's got a 0.4 chance of hitting, a 0.6 chance of missing. They're the two possible outcomes. So what this, oh, it's not 5, it's taking 10 shots. So if we were to, the binomial distribution is represented by this expansion. So the binomial probability distribution is represented by this expansion, if that makes sense. So if we expand this out, we're going to see everything. Can you imagine it? It would read 0.4 to the power of 10. Well, that would be 10 naught, which is 1, by 0.4 to the 10, by 0.6 to the 0, if you want to go there. Now what does that represent? That represents 10 successful shots. Gets all of them. Okay, what's the next one? Next one is 10, 1, 0.4 to the power of 9, 0.6 to the power of 1. What does that represent? That represents 9 successes, and 1 fail. 1 fail, 9 successes, 1 fail. How many ways can we get that? 10 to the 1 ways. Because he can miss on his first, his second, his third, or fourth. You get the idea. The full expansion gives us everything. Now look at this. What is the probability that he is successful with exactly 5 shots? So this is like saying with a binomial expansion, what's the coefficient of x to the power of 5 in a power 10 expansion? So what we're interested in here is a specific 5 successes. So the result, the answer, is 10c5 by 0.4 to the power of 5 by 0 times 0.6 to the power of 5. 5 successes, 5 fails. This 10c5 ways of that combination appearing in 10 shots. So this can be done on a calculator. This is going to be big. This can be done on a calculator. I'm going to get the calculator on the screen and show you that. Okay, so 10c5. Now how do we do that? We go through menu, we go through 5, we go through 3 for combinations. So we go 10, comma 5. That's my 10c5. Now I'm multiplying that by 0.5, no, not 0.5, sorry, 0.4 for successes to the power of 5, 5 successes, times, no, not up there, times 0.6 to the power of 5. Hit enter, 0.200658. 0.200, so we'll go back over here, 0.200658. Now that's the probability of exactly 5 successful shots. I'm going to show you how to do this in one move on the calculator. So we'll go back to the calculator, and in here we've got a function under menu 5, distributions 5. So that's menu 5, 5. Now we're going to go to letter D, because that's going to bring up binomial PDF, probability distribution function. Number of trials. I'm just going to punch in there how many trials we've got. The probability of success is 0.4, and I want 5 successes. I hit OK, and I get 0.200658, done in one hit. So this, the calculator just reads off exactly the same that calculation. Okay, let's go back and answer another question, perhaps a more realistic one. Now this is asking, this part B, what is the probability of at least 5 successes in 10 shots? So this is asking for, what I just got, so 5 successes, right, which is this, by 0.6 to the power of 5, plus 6 successes, 0.4 to the power of 6 by 0.5 to the power of 4, because that's 4 fails, plus, right, 7 successes, right, you get the idea, 0.6, this should be a 0.6 here, sorry, 0.6 to the power of 4, 0.6 to the power of 3, this goes on up to 10, 10, 0.4 to the power of 10. Okay, massive calculation to be done there. We could do that, sure. There's a fast way on the calculator. Let's go to it. It is here. So we go through menu 5, 5. That gets us into probability distribution, you see. Now, normal PDF, we're going to come to that. I might just walk you through all the options. We go down. Poisson's coming up as well. That's another discrete random probability distribution. But we're in here, binomial PDF. PDF is for a singular value, like we just worked out. CDF is cumulative. Go to CDF. Look at this. We've put in the number of trials, the probability of success, plug that in. Now the lower bound, we want at least 5. So we want 5 to 10. Look at what this does. This adds up all the probabilities from 5 to 10. We hit OK, and there's our answer, 0.367 to 3 significant figures. 0.367 to 3 significant figures. The probability of at least 5 successes in 10 shots. All right, so this is a really popular question. This is the last one I'm going to ask before I get, this kind of rounds it off, I suppose. So you'll be able to go and do some questions after I've done this example. Right, so let's have a look at it. What is the minimum number of attempts for Jim to make so that the probability he makes at least one successful attempt is at least 99%? Wow, that's a big question. All right, let's break this down. So we're after the minimum number of attempts for Jim to make. So imagine he's shooting at the target. What we want is to find out how many attempts he needs to make with his success rate of 0.4 so that the probability that in that group of however many shots he has, the likelihood that he'll make at least one successful attempt is now greater than 99%. This seems kind of crazy, but let's have a look at this. So the probability, what's asking for, the probability of, what's this? Of the at least one success is greater than or equal to 0.99. The probability of at least one success. Now, whenever you see these words at least, you should be thinking, oh, what is the complementary event to that? Because at least one is 1, 2, 3, 4, 5, 6, 7. The complement is 0. He's either going to get at least one success or he's going to get no successes. And that's only one calculation you need to make. So why don't we turn this around and say, well, this just means exactly the same as 1 minus the probability of no successes. And that is greater than or equal to 0.99. Now that is the same as saying no successes is all fails. Is greater than or equal to 0.99. Now what's the probability of all fails? Well, this, so let's maybe we should just reorganize this so that we've got the probability all fails is, what is that? Less than or equal to 0.01. How's that look? Okay, so can we write this probability of all fails? All fails, so that is the probability of failure is 0.6. If we're going to have n attempts, which is what we're trying to solve for, we're trying to find out how many attempts, how many failures in a row, such that we get below this magical mark of 0.01. So this is what it boils down to. we can trial and error this, or we can be a bit more savvy and solve it using logs. So whenever we've got an unknown in our power and our exponent, logs comes to the rescue. So therefore, let's take the log of both sides and bring the n down. We'll have n log 0.6 is less than or equal to log 0.01. Now, all right, that looks good. Now we're going to divide by log 0.6, but beware, this is a negative value. Log of, I'm going to highlight this because this is a potential area of, this is a potential trap. Log of 0.6 is less than 0. So that means when we come to making n the subject here, we've got an inequality when we're going to be dividing by a negative number. So what does that do to my inequality? It turns it around. Turns it around because when you divide by a negative, your inequality changes direction. 0.01 over log of 0.6. Okay, let's put this in our calculators. Log of 0.01. Here we go. Where's my log? There. Log of 0.01. I'm going to divide that by my log of, what was it? I've forgotten. Log of 0.01 was divided by log of 0.6. Log of 0.6 goes in there, 0.6. Hit enter. I get 9.015. What do I do with that number? N has to be greater than or equal to 9.015. But what does n represent? It represents the number of trials. So the minimum number of attempts, therefore the minimum number of trials to give Jim a better than 99% probability of at least one success is 10, because that's the next number up. Okay, so now get some practice. I'll see you in the Zoom meeting at well, soon. See ya.